Okay, everybody, this is chapter 9, section 4. This is a composition of isometry. So we're going to get some vocab here, but it's really just doing, putting together different things that we've done so far. So far in this chapter, we're moving stuff around. They're called transformations. We've done a translation, which means I kind of shoved it in an X and a Y direction. We've done a reflection, which means I have to have a line to reflect something across, so like the y-axis. And then we've done rotations, and we've done rotations at 90 degrees, at 180, and 270 is what we're doing. We have to change the x and y values a little bit to do those, okay? So that's all the transformations were done. So isometries are kind of taking these and doing a couple different things, okay? So long definition because they're adding all those words, but an isometry is a transformation, which is a translation, a reflection, rotation that preserves distance or length. So we kind of learned that before. You don't need to write down theorem 9.1 because that's what we just said in the definition, okay? But we are going to do two or more, right? In example number 1, you don't need to write this down, but we're just looking at which of these letters or images of each other, what kind of transformation took place. So just very quickly, if you looked at B and D, I believe they're a transformation of each other, and it looks like I reflected them really across C, so that's a reflection. So I use capital R for that. If you looked at P and Q, that would be another reflection, you know, whatever the line was in between it. Okay, so that'd be a reflection. All right. If you look at something like the letter N and the letter U, I believe those are transformations of each other, but I don't think I reflected it. It looks like I probably rotated it, so they're a rotation of each other. Okay. If you kind of went back and looked at P and Q and B and D, you know, you pick like B and P could be a reflection. I could have reflected it like if there was a line above the P or below the B, I could have reflected it, or I could have rotated it. So kind of the same thing. I could, or two different things. I could also say that about D and Q. It could be a reflection if there was a line above the P or below the D, or I rotated it, okay? So we're going to kind of look at different ways we move stuff and label it. I have to give it rules, okay? The one here, composition here, is the combination, okay? So this really means like two or more, right? Two or more transformations. Remember, transformations are a translation, a reflection, or a rotation. Okay? All right, and example number 2, if you got to draw that, you need to, but what they're saying here, you got to read the directions here. Okay? The solid figure is the pre-image of the dashed figure. Okay? The dashed figure is the pre-image of the dotted figure. So hopefully you can kind of see the differences in those, okay? So right down here, we're giving you kind of some rules. So just writing it out in sentence form, but some rules, and we got to match the rule to picture A, B, or C, okay? All right. So I'm going to move pretty quick. So once again, if you need to hit pause, you can get your notes caught up and then hit play and come back, okay? So I'm going to rotate. Now remember, I'm starting with the solid, okay? And then I'm going to dashed, and then I'm going to dotted, okay? So just keeping that in mind, okay? I'm going to rotate around P and then translate it perpendicular to line M. So I'm going to turn it counterclockwise around P and then translate, which means I'm going to shove it perpendicular to line M. So it means I'm going to cross it at a right angle. Okay. So taking a look at that, which one do you think it is? Okay. We'll rotate around P. So I'm looking, starting with the solid figure like here. Did I rotate this around P to get to that dashed figure? Doesn't look like it. Okay. So let's go here. Here's the solid figure. Did I rotate it around P counterclockwise? It looks like I did. And then did I translate it perpendicular to line M? Well, shoving it. Did I shove it and keep it the same way? It looks like I did. So I believe that number 1 is B. Okay. So hopefully you can follow that. All right, so once again, going back to the solid figure, I'm going to translate it parallel to line M. So I'm going to give it a shove, and then I'm going to reflect it in line M. So I'm going to flop it over line M. So I'll start here again. Did I translate it parallel to line M? Remember, parallel means I don't cross it. So that looks pretty good. And then I'm going to reflect it in line M. So did I flop this over line M? It looks like I did. Okay, so number 2 should be A. Okay, so last one, it must be C, but let's just make sure. Okay, we're going to reflect it in line M, and then we're going to rotate it around P. So did I reflect this across M? So remember, I start with the solid. Okay, and then did I rotate it around P? And looks like I did. Okay. All right, so kind of a nice way to start doing that. This is one transformation, this is the second. One transformation, then the second. So that's what makes up compositions, okay? 2 or more. We did 2 in each one. Okay, so we're going to go here. This little symbol, I forget the name of it, sorry about that, but it tells me that I got to do two movements. Now, one thing let's write this down. You have to, and I'm not sure why we do this, but it is kind of something that comes up in Algebra 2 when you're working with functions. You're going to do the second one first, and the first one last. Okay, so this is the second one. This is the first one. Okay. So I'm going to take these 2 lines, M and L, and I'm going to reflect the letter J. Remember, capital R is reflection. J across lines, but I have to do this one first. Okay. So I'm going to keep distance. I got to keep distance from L. So I got to go the other side, same distance. Hopefully that's the same distance. But remember, I reflect it so it kind of flops. So it's going to look like that. Okay. Good there. Okay, then I go and do the first rule last. So I'm going to do that one. Okay. So I'm reflecting across M. Now from where J is to M, okay, I got to go the same distance away. So that's pretty far. So hopefully that's far enough. And I'm going to flop it again so it kind of ends up over there. Now a lot of kids will say, why doesn't it end up back to where it started? You have to keep distance from whatever point or line you're using as reflection. Okay. So hopefully you got that. All right. Okay, a glide reflection is a composition of a reflection and a translation. So it's just a specific name for doing specific things. Okay. So not a huge deal, but it's just words that you'll see. So a glide reflection is just kind of a unique thing made up of specific transformations. Okay. All right, so what we're going to do is on this graph, we're going to go ahead and graph these 3 points, okay? So -5, 2 is here, -1, 3 is there, -2, 1 is here. Draw in your triangle. This is T, this is E, and that is X, okay? All right, they give me this glide reflection rule, so you probably want to write that down. Okay. and I have to do the second one first and the first one last. So the second one is the capital T member stands for translation. So I'm going to move these an X value and the Y value. So the X value is 0, so I'm not going to have to go left or right. But I am going to have to go down 5 for each point. Okay, so let's start with T. I'm right here. I got to go down 5. I think it gets me to here. That's T prime. I'm going to start with E. That's 3 at 3. So I got to go down 5. I think it gets me there. So E prime. And then X is here. So I got to go down 5. I think I get to here. Okay, prime, X prime. Go ahead and draw in your triangle. Okay, that's where I moved it by translation. But now I got to do reflection. And it's a reflection across X equals 0. This is kind of tricky. We're kind of messing with you here, okay? Where does X equal 0? Right here, which is the origin. But where else does X equal 0? Well, I believe it's all these points right here. X has a value of 0, okay? So really, what is that? It's the y-axis. Well, why didn't we say that? Well, we could have, but we can name it something else. So it would have been easier saying the y-axis, but, you know, like I said, we're messing with you. Okay? Weird math teachers. Okay, so I'm reflecting it. So remember, I'm keeping distance. So let's start with E. It's 1 away from that line. I'm 1 away to the other side. We'll call it E prime prime. Okay, I'm at, let's go to X. I'm 2 away, so I got to go 2 to the other side. X prime prime. T, I am 5 away, so I got to go 5 to the other side. And that's T prime prime. So I can draw in my triangle. Looks like I took my spatula out with my pancakes and I flopped it over. Okay, so I went pretty quick. I might want to go back over and replay that part just a little bit, but that's an isometry. It's a composition of transformations. And this one was specifically a glide reflection because it was a reflection and a translation. Do the second one first and the first one last, okay? All right. So that's a lot of practice. You're going to need a lot of graph paper for that. Just make sure that you draw your stuff and keep in mind a couple of those simple rules, okay? Thanks.